Hello, and welcome to this presentation. My name is Kurvash Kerendish. Today, myself and my peer, James Blackburn, aim to bring to you an informative presentation on the Seveso disaster. The presentation aims to discuss this event by considering many aspects related to this topic. The discussion will consist of the following sections: background to the companies responsible, and location of the event. We then move on to talk about the purpose of the plant and its production. We will see in details how the accident took place. James will then discuss short-term and long-term effects of the incident on the company, people, national economy, and the environment. This is then followed by the cleanup process for the years to come after the incident. A risk assessment list is also suggested by me and James for the chemical process that led to the disaster. Let us start by looking at the background. The incident happened about 12 miles north of Milan in a small town called Seveso, located in the Lombardy region of Italy. The accident is recorded to have taken place around midday of July 10, 1976, when the population of Seveso was approximately 17,000 people. Here you can see a map of the region where the plant was located. The plant was owned by a company called Mida Chemical, also known as ICMESA. The company was a branch of Swiss Roche Group. We now move on to the next section of the presentation, where we discuss the purpose of the plant. One of the main products generated by this plant was hexachlorophene. This chemical was shipped out to medical centers, where it was used to clean the patient's skin before a surgery to prevent bacterial infections. For the production of hexachlorophene, a molecule of a chemical called 1245 tetrachlorobenzene was reacted with sodium hydroxide to produce an intermediate molecule known as 2,4,5 trichlorophenol. The reaction pathway these molecules take is known as a nucleophilic aromatic substitution. 2,4,5 trichlorophenol was then further reacted with sodium hydroxide in the presence of heat to produce hexachlorophene. In the reaction vessel, the mixture was heated to 158 degrees Celsius, very close to the mixture boiling point, which is 160 degrees Celsius. To supply the heat to the mixture, steam was used. The heat from the steam was indirectly applied to the mixture. The steam itself was heated by the electrical power supplied by a water turbine on site of the chemical plant. The temperature of the steam was 190 degrees Celsius at the pressure of 12 bars. Now that we know what the chemical plant aimed to do and the process it used, we can move on to discuss the reasons why the incident happened and how it could have been prevented. On this slide, you can see the overview of the plant. The accident happened in Building B. About 10 hours before the incident, the final stage of the production of hexachlorophene was disturbed, as there was an emergency conference with the Italian government, requiring the plant to shut down over the weekend. The final stage of the process was a batch distillation aiming to separate ethyl glycol from the mixture. As all the other plants had completed their process, the person operating our target plant turned the stirrer and the whole process off without any awareness of whether the process was completed or not. Over the next few hours, a series of events took place that led to the catastrophic Seveso disaster. As the rest of the site was under no operation, the power supplied by the turbine was in excess. The excess power from the turbine slowly heated the steam beyond the temperature needed. It is estimated that the steam was overheated to around 300 degrees Celsius. The overheated steam subsequently overheated the mixture in the reaction vessel. It was experimentally estimated that the reaction should not be heated to more than 230 degrees Celsius. This was as the exothermic decomposition of the reaction mixture to dangerous chemicals such as dioxin would occur at such high temperatures. The exothermic component of the event also means that the rapid rise of temperature could occur as a result of energy release from decomposition. Despite the clear risk of overheating and potential for explosions, there was no steam temperature data provided to the operators of the plant. This meant that any changes in the steam temperature could not have been observed, and the temperature was wrongly assumed to be constant at all times. This, however, was not the case, as the changes in power supplied to heat the steam were not taken into account at all. Another big problem was the localization of heat in the reaction mixture. As the stirrer at the bottom of the reaction vessel was turned off by the operators, the side of the reaction vessel adjacent to the steam flow was heated, resulting in a small portion of the mixture being overheated. The lack of stirring meant that the heat was localized in a small volume, multiplying the overheating effects. This caused a temperature rise over the critical temperature of 230 degrees Celsius in the reaction mixture. As a result of the temperature rise, the exothermic decomposition of the chemicals started. The pressure inside the reaction vessel slowly built up over the hours. The high pressure caused the relief valve at the top of the vessel to pop off, leading to the release of dioxin in the air.
The Seveso disaster had many effects on the environment, health of residents in the affected areas, and those responsible. The main adverse effect of the disaster was the exposure to tetrachloride dibenzoyl dioxin, or TCDD for short. Thousands of people were exposed to this chemical through its airborne transmission. 15 children were immediately hospitalized with skin inflammations, and once it was found that something disastrous had happened, mass evacuations of affected areas took place. 3,300 animals would be found dead from exposure to TCDD, and by 1978, a further 80,000 animals would be slaughtered in order to protect the food chain. As this graphic shows, 3 zones were established with varying levels of TCDD, Zone A being the most highly concentrated. By August after the disaster, Zone A had been entirely evacuated and fenced off, with other areas being quarantined. Local produce was also banned as it was deemed unsafe. Many health effects from this disaster would become known and studied. Shortly after the disaster, 447 cases of skin lesions and chloroacne were confirmed, and chloroacne would become a directly established health effect of TCDD exposure from a 1991 study where 193 cases were still present. In addition to this, many other effects were studied from the residents exposed. Excess rates of numerous diseases were observed. Excess rates in cardiovascular diseases, respiratory diseases, endocrine-related diseases, diabetes, and cancers, to name a few. The company responsible, ICMESA, or ICMESA, were held accountable for the disaster, and 2 officials, the technical director and the director of production, were arrested. By May 1986, 2 other ICMESA employees would face up to 5 years imprisonment from an ongoing criminal court case. The aftermath. Evacuation began 2 weeks after the incident, with the Italian government tasked with understanding what had happened and trying to safely deal with the situation. In January of 1977, an action plan was established involving scientific analysis, economic aid, and restoration of the area. $47.8 million were raised for new government commissions to decontaminate the area. ICMESA would also agree to compensate the residents and the government with up to 20 billion lire. It could soon be seen that the factory had very basic and rudimentary safety systems, and environmental protection had not even been considered, nor any warning system or health protection protocol been put in place. In 1982, the Seveso Directive was passed, which imposed much stronger industrial regulations. This directive would also be updated in 1996, 2008 and 2012. Eventually, contamination levels were treated to a safe level, and studies of the health of the population are still ongoing to establish more effects of long-term exposure to TCDD. The main risk recommendation we would have concerns the dioxins, which would be to have correct measures to prevent leakage of potential dioxins. Here is a prospective risk assessment for the IMESCA plant.